One of the most fascinating mysteries of the universe for me is the life cycle of a star. It's a process that begins with the formation of a star and ends with its death, a grand explosion or a quiet disappearance. Today, I want to share my thoughts on this amazing journey a star takes throughout its life and how its mass determines its future. Stars go through several stages depending on their mass. Every star begins in giant molecular clouds, where gravity compresses gas and dust, creating the conditions for nuclear fusion to start. This is a process of immense power that sparks the birth of a star. When the temperature and pressure in the center of the cloud become sufficient, the reaction begins, and a protostar appears. This is its first stage, when the star is just starting its journey. Next comes the most stable and longest phase, the main sequence. This is the stable life stage of a star, when it converts hydrogen into helium through nuclear fusion. The Sun, for example, has been on the main sequence for about 4.6 billion years and will continue this phase for about another 5 billion years. But over time, the star depletes its fuel. When the hydrogen in its core runs out, reactions slow down, and the star begins to contract under the influence of gravity. The outer layers of the star begin to expand, and it turns into a red giant. This can be a truly magnificent event. At this point, the star starts to synthesize heavier elements, such as carbon and oxygen. The death of a star depends on its mass. Low-mass stars, up to 8 times the mass of the Sun, experience a calm death. After the red giant stage, they shed their outer layers, forming a planetary nebula, and the remaining core becomes a white dwarf. This process is quiet, but still important for the universe. As for massive stars, more than 8 times the mass of the Sun, they end their lives much more dramatically. After the red supergiant phase, they may explode in a supernova, releasing an enormous amount of energy and material into space. These explosions are significant. They enrich the interstellar medium with heavy elements, which later become the foundation for the formation of new stars, planets, and possibly even life. This is a kind of cosmic rebirth. As a result of a supernova, elements like gold, platinum, and even uranium can be ejected into space. Substances that could later become part of planets, including Earth. For example, carbon, nitrogen, and oxygen, which make up our cells, were formed in stars and were thrown into space during supernova. After the explosion, the remaining core of the star can become a neutron star if the star's mass wasn't too large, or a black hole if the star's mass was sufficient. Neutron stars have incredibly powerful magnetic fields, which can be 1 billion times stronger than Earth's. These fields are so strong they can bend space around the star and influence the movement of particles in nearby space. Black holes, on the other hand, become gravitational traps, absorbing everything that falls into their field. And how can we not mention our Sun? It's a star of average mass, and in the future, it will also become a red giant. However, its death will not be as catastrophic as that of more massive stars. When the Sun expands, it will engulf the nearby planets, Mercury and Venus, possibly even Earth. But there's no need to worry. This process will occur in about 5 billion years. Thus, the life cycle of a star, from its birth in a gas cloud to its death in a supernova or white dwarf, fills the cosmos with incredible energy and wonder. And the most amazing part is that the death of a star doesn't mean its end. On the contrary, it's the beginning of a new phase for the universe, a new cycle in the endless process of creation and destruction that continues infinitely. I hope this video was useful and interesting for you. Please give it a like. It will be a great indicator for me that the content is worth it. I'll continue working on improving and creating even more captivating videos for you.